Hello, Luke. Welcome to lesson 35. So today we will be discussing factoring the greatest common factor, and then we'll move on and talk a little bit about canceling, which is kind of related. So to begin with, let's talk about factoring the greatest common factor. And to start that conversation, we really need to go back to the distributive property. So let's say I have an expression that looks like this: 3 times a plus b. Okay, I might ask you to expand this, and you should recall that expansion just means using distributive property. So we multiply this 3 through the set of parentheses. So we multiply it by the a, that'll give us 3a, and then we multiply it by the positive b, which gives us a positive 3b, right? And that would be our answer for this expansion problem using distributive property. Okay, so one thing I just want to point out and make sure that you recognize, because this will become very important, especially in canceling when we start talking about that, is the fact that in this original problem, this original expression, we need to recognize that this is, in fact, a multiplication problem. All right, and as all multiplication problems do, it must have factors in it. All right, remember, a factor is just one of the numbers being used in a multiplication problem to get an answer. All right, so here, where is the multiplication in this problem? Well, it's right here. It's 3 times a plus b. Okay, so the first factor, and again, whenever I say factor, you should be thinking multiplication. All right, so the first factor in this problem is the 3. Right? That's pretty obvious. That's the first thing that's being used in this multiplication. The second factor is what, though? The second factor is actually this whole set of parentheses, the a plus b. That whole set, group is the second factor. Okay? So whenever you see parentheses, think of them as a container. Okay? And it really doesn't matter what's in that container. Everything is going to be multiplied or added or divided or what have you to the rest of the problem. Okay, so in this case, we have a container and it's being multiplied by the 3. Okay, so the second factor is the container, which is the parentheses. There is addition going on in here, but that's secondary. That's kind of within the parentheses. That's kind of its own separate little part of the problem. So the main piece of the problem is the parenthesis. That's the bucket, you might say, the container. And that's what's being multiplied by the 3. Okay? So you might think of it as 3 times the bucket. Okay? Or 3 times the container. The second factor is the bucket, is the container. And that is these parentheses right here. Okay? All right, so that is something to bear in mind because that's going to play into what we're going to discuss in the next couple of minutes here. So the goal now, now that you've just reviewed really how the distributive property works, we get to this point. Today, when we talk about factoring the greatest common factor, we're actually reversing the distributive property. Okay, so we're starting with this, and we're trying to get to this. Okay, we're trying to work backwards. Okay, so how would we do that? Well, the answer is recognizing that distributive property always relies on multiplication. There's always multiplication in distributive property. So if we're trying to get from this to this, we know right away that there has to be multiplication going on to get to this distributive property. Okay, and what are we multiplying? What are the two factors? Well, there's going to be one factor and there'll be a second factor. That's a little messy. One factor and then there'll be a second factor. So the question is, how can we factor this? How can we divide this up into different factors, into two factors? And the answer is in something that we've already learned, which is the greatest common factor. All right. So the first step, I'm going to put that right over here. The first step is find the greatest common factor. Okay? When we're trying to undo the distributive property, we're going to find the greatest common factor. The GCF. Okay? So to do that, we look at our 3a plus 3b, and we say, what's common between these two terms? And the answer is, it's a 3, right? That's the only thing that's common between 3a plus 3b, right? So that would be the greatest common factor. So we're going to write that right here, okay? Now, this is where we get to the crux of the work here. Now we're going to place a set of parentheses right next to this 3. That's going to be the second factor. Remember, it's the bucket, all right? We know that 3 is common, so we're going to pull that out and set that out here as our greatest common factor. And then we're going to multiply that by the bucket. And the bucket is going to contain everything else that is not a common factor, okay? So we take this first term, the 3a, and essentially what we're going to do is we're going to take our greatest common factor, which is a 3, and we're going to divide out that 3 from this 3a term. So if we think of 3a divided by a 3, well, the 3's are going to cross out. We're going to be left with an a. So that's what's left over. This bucket is for picking up the leftovers. So we put all of our leftovers into this bucket. So we have an a that's left over. So we put the a here. Then we have our addition sign. And now we have this second term here. And we're going to do the same thing. We're going to divide this by the 3, the greatest common factor. Okay, the 3's again will cross out, and we're left with just a b. So we write the remainder, or the leftovers, in our bucket, and we end up with a plus b. Here is what we're trying to get to. This is actually what we started with, the 3 times a plus b. All right, so if we're trying to undo distributive property, the first step is to find the greatest common factor. All right, the second step is just to factor out the greatest common factor from all terms. I won't even say other. Ooh, pushing too many buttons here. From all terms. Okay. And then maybe the third thing would be write the leftovers in parentheses. Okay, so hopefully that kind of makes sense. We're first finding the greatest common factor, then we factor out the greatest common factor. And when I say factor out, it's just another way of saying divide out. So I'm kind of dividing out the greatest common factor from all the terms, and then I write the leftovers in the parentheses. Okay? All right, so let's try a couple more of these and see how we do. So these are obviously a little bit more complicated, but the procedure is the same. So we have an expression here. We have 3 terms, right? And we're going to start by trying to, well, and again, the goal here is we're trying to factor out the greatest common factor. So in other words, divide out the greatest common factor. Okay, so let's first find the greatest common factor. What is it? So hopefully by this point you've had some practice with this and it's pretty easy for you. But if we're looking for the greatest common factor, right? And I'm looking over here and I'm going, okay, so I have an x to the third. This one has an x, and this one has an x. So all 3 terms have an x. So we know that the greatest common factor is going to contain an x. But we need to know to what power. This one, the x to the third, x to the second, x to the second. The most that we can pull out of all of them would be 2, right? So we have x squared that we're pulling out. You might think of it as just find the smallest exponent. Okay, the smallest exponent is a 2, so that's what we pull out. All right, now the next one, we have a y squared. So this one has a y, this one has a y, and this one has a y. Yay, all 3 have y's, so we are going to have a y in our greatest common factor. What will be the power of that y? Well, we have the power of 2, the power of 1, and the power of 3. So the smallest power, or the greatest number of y's that we can pull out of all 3 of these would be 1. Okay, so we have just y to the 1. Then we have our a, and lo and behold, they all have a's. So we know a will be in here. A to what power? Well, we have a to the 4th, a to the 3rd, and a to the 3rd. So a to the 3rd is what we can pull out. So that is our greatest common factor. So we're going to write the greatest common factor outside of a set of parentheses. x squared y a to the third. And we're just going to set next to that a big bucket, big container, okay, that we will be multiplying the greatest common factor by, okay? So inside this container, we will put all of the leftovers after we've factored each term or divided each term by the greatest common factor, okay? So let's take the first term here, x to the third. Well, what did the greatest common factor have? The greatest common factor had x to the second. So if we have 3 x's and we're taking the 2 x's away, we're left with just 1 x here, right? So the leftovers here are 1x, all right? Now the y, we have the greatest common factor. It has a power of 1. This one has the power of 2. So if we take away the 1, we divide out the 1, we're left with just 1. So we just have 1y left. The a, well, here we have a to the third. So if you take away 3 a's, we're left with just 1a. So we have just a. Okay, so that's dividing out the greatest common factor from the first term. And if you didn't understand that, just real quickly out to the side, if I have that first term, I'm just rewriting that first term. Okay, all I did was mentally divide out the greatest common factor, x squared y a to the third, okay? And we're just saying, well, this x2, that's going to cross out 2 of these x2s, and we're going to be left with just an x. This y will cross out 1 of these y's. We're left with just a y. These 3 a's will cross out 3 of these a's, and we're going to be left with just an a, okay? So we have an xya, okay? Does that make sense? So let's keep going. Now we have a plus sign, all right? And we're going to divide out our greatest common factor again. So we have an x squared and an x squared. Well, that totally eliminated it. And so we're just left with a 1. Okay, x squared divided by x squared is just 1. Another way to think of that is, I have 2 x's, I'm taking away 2 x's, so I'm left with 0 x's. Well, that would mean that this is x to the 0, okay? Which, remember, always equals 1. Anything to the 0 power always equals 1, all right? So now we have a y and a y. And again, the 1 minus the 1 is a 0. Well, that's just going to be a 1 as well. So we have 1 times 1. Okay, then the a to the 3, well, lo and behold, again, the a to the 3 just crosses out, and we're left with just another 1. So we really have 1 times 1 times 1. Okay, and I think I'm going to need just a little bit more room here, so we'll move this parenthesis down a little bit. Okay, and then lastly, so we have our minus sign, and our last term, x squared is going to give us the 1 again, right? And then the y1, y to the third, that's going to give us y squared. A to the third and an a to the third, well, we divide those out, we're going to end up with just a 1. Just to show that, we'll write it here. Okay, so those are the leftovers after we've divided out the greatest common factor. So now we can kind of maybe simplify that, maybe write it a little bit nicer. We have x squared y a to the third. And then the first term, xya plus, now 1 times 1 times 1, that's just going to be 1, minus 1 y squared times 1, well, that's just y squared. Okay? And now we have a problem that would, if we were to expand it, would require us to use distributive property. So we've factored out the greatest common factor. Okay? Now, if you wanted to check this, you certainly could. Just expand it. Take this first term and expand it through the set of parentheses, and you should end up with what we started up at the top. All right? And if we do that just real quick, multiply that through, we end up with x squared times an x, which is x to the third, y times a y, which is a y squared, a to the third times a, which is a fourth. All I've done is just taken in that term and multiplied it by this term. Now we can take that outside term and multiply it by a 1. Well, that's just going to give us the outside term, right? And then we can multiply it by a negative y squared. Well, that's going to give us a negative. The x squared isn't going to change. Y will become y to the third, and then a to the third. And if we compare that to what we started with up here, we'll notice that it is, in fact, exactly the same. So we know then that this was a correct factorization of this first expression. All right, let's try another one now that we've kind of got the method down here. So if I have this expression, let's first find the greatest common factor. That's the first step. And maybe actually we'll just write it right away down here. We know we're going to have our set of parentheses. And outside of that bucket, we're going to have our greatest common factor. Okay, so let's start with our greatest common factor. Let's see here. They all have z's. So we know z is going to be part of it. And what's the lowest exponent? Well, it's a 2, so it's going to be z squared. Now we do have m's in all of these, right? And the lowest exponent there is 1, so we just have an m. And then we do have a y in all of these, and the lowest exponent there is 2, so we're going to end up with y to the second, and that's everything. So that's our greatest common factor. Now we can put whatever's left over into the bucket, all right? So we have a z to the third divided by a z squared. Well, that's just going to give us a z, right? M squared, we take away the 1, we're going to end up with another m. Y squared divided by y squared is a 1, so I'm not going to even write it. It's just z times m times 1, which is zm. Then we can continue with our plus sign. Z squares will cross out and give us a 1. M will cross out and will give us a 1. Now, y2, we're going to take away 2 of these 3's, or 2 of these y's, and we're left with just 1 y. So we end up with 1 times y, which is just y. And then we have our minus. Z squared from z to the fourth will be z squared. M to the m to the third is m to the second. Y squared, that's just going to give us a 1. So there we have it. That is our factorization of this expression. All right, and that's how they'll term this. You know, factor this. That's what they're, when they say factor that, that's what they want you to do. They want you to find the greatest common factor, pull it out, and divide every term by it and place it in parentheses. Okay? Excellent. Let's just do a couple more here real quickly. Why don't you pause the video, try this next one on your own, and then we'll do it together. All right, so if we're going to factor this out, we have some numbers here first, right? So let's find our greatest common factor. Let's take the numbers first, 2 and 4. What's the greatest common factor of 2 and 4? Well, that's a 2, right? It's the largest number that can go into both of those. All right. And now we have b to the third and b to the second. Well, the largest one that can go into both of them would be b to the second. C to the fourth and a c, the largest one again would be a c that can go into both. Or another way to think about it is which one is the one with the smallest exponent. And then we have h to the third and h to the fourth. Well, that's going to give us h to the third, right? So there's our greatest common factor. Now we need to place our container for the leftovers. So if we divide this first term by the greatest common factor, we have, 4 divided by 2. Well, that's going to be 2. B to the third divided by B to the second, that's going to give me a B. C to the fourth divided by C, C to the third. H to the third divided by H to the third, that's 1, so I'm just going to leave it out. Then I have a plus. 2 divided by 2, well, that's 1. B squared divided by B squared, that's 1. C divided by C, well, that's 1. And H to the fourth divided by H to the third is just an H. So we're just left with an H on that side. So that would be our factorization. Pretty straightforward. Okay, let's try the next one. Pause the video, give it a try. All right, so here we have some numbers. We have a 12, a 3, and a 4. What would be the greatest common factor for those 3 numbers? Well, hopefully you can do that in your head. It's going to be a 3, right? 3 can, all right, no, actually. Oh. I don't like this at all. We are going to change this. Let's make this a 16. That was a typo. That one actually didn't have any greatest common factor between them, which is okay. It just would have made the problem a little bit larger in terms of its numbers. Okay, so let's start with the 4. Okay, so we have a 12 and a 16. I better redo this and completely. All right, so let's try some more here. Why don't you pause the video and give this one a try, and then we'll do it together. All right, so let's find the greatest common factor. We'll start with the numbers. We have a 4 and a 2. What would be the greatest common factor of those? Well, it would be a 2, right? That's the greatest number that can go into both of those. All right, so we have a 2. Then we have a b to the third, b to the second. Well, the greatest one that can go into both of those would be b to the second, c to the fourth, and a c, well, would be a c. H to the third, h to the fourth would be h to the 3, right? And then we have to put our parentheses here, our bucket, to contain everything else. So let's divide this first term by the greatest common factor. 4 divided by 2 is going to give us 2. B to the third divided by b squared, that's going to give us a b. C to the fourth divided by a c is going to be c to the third. H to the third divided by h to the third, well, that's just going to be 1, so we'll leave it out. Then we have our plus sign. 2 divided by 2, well, that's 1. B squared divided by b squared, that's 1. C divided by c is going to be 1. H to the fourth divided by h to the third is going to be an h. So we really have 1 times 1 times 1 times h, which is just h. All right, so that would be the factorization of this expression. All right, why don't you try the next one? Pause the video, and then we'll do it together. And actually, before you do that, though, I'm just noticing that this problem is going to be made a lot easier if I change this number. Let's change this number to a 16. All right, I like that better. All right, so go ahead and pause the video and give that a try. All right, so let's divide out our greatest common factor. So our greatest common factor between our numbers, we have a 12, a 16, and a 4. The largest number that can go into all three of those would be a 4. So that's going to be the greatest common factor. For the a's, we have an a squared, a to the third, a to the fourth. It's going to be the a squared. B squared, well, we have a b squared, a b to the third, and a b to the third. It's going to be a b squared. We've used up all of the components to this term, which is great. There is a c over here, but the rest of them don't have c's, so that one we don't even have to worry about. That's just an unmatched sock. We just don't worry about it. Okay, so let's then place our container, and we put our leftovers into the container. So we have 12 divided by 4, which is 3. A squared divided by a squared is just 1. B squared divided by b squared, well, that's just 1. So we end up with just a 3 in the first term. Then we have plus. Now, the second term divided by the greatest common factor is going to give us 16 divided by 4, which is 4. A to the third divided by a squared is going to be a. B to the third divided by b squared is going to be a b. Then we have our plus. Moving on to our third term, 4 divided by 4 is 1. A to the fourth divided by a to the second is going to be a to the second. B to the third divided by b to the second is going to be a b. And c to the third divided by nothing over here is just going to give us c to the third. Right? That one, nothing happens to him. All right, that would be then our factorization of that expression. Okay? Very good. All right, Luke, so this is actually covering just half of the lesson, but it's getting a little bit long. So I think we're going to stop here, and we'll pick up the second half of the lesson tomorrow.